There is a man who looked at reality, the same reality you are sitting in right now, and said, "You have no idea what is actually going on," not as an insult, as a fact. Richard Feynman was one of the most brilliant physicists who ever lived. Nobel Prize winner, Manhattan Project veteran, the man who famously diagnosed the Challenger space shuttle disaster with a glass of ice water. But his most unsettling contribution wasn't a discovery about the universe. It was a way of seeing it. And once you see it his way, you cannot unsee it. Because here is what Feynman understood that almost nobody talks about. The reality you experience every day, solid objects, predictable paths, cause and effect, is not the real reality. It is a kind of average, a blurry shadow of what is actually happening underneath. At the deepest level, reality is not made of certainties. It is made of possibilities. And the rules that govern it are so strange, so completely counterintuitive, that Feynman himself said, and I am quoting directly here, "If you think you understand quantum mechanics, you don't understand quantum mechanics. So let's go deeper than anyone usually does." 5 ideas. 5 ways Feynman completely shattered how we think the universe works. By the end of this video, you will never look at a table, a beam of light, or your own thoughts the same way again. Let's start with the one that breaks most people's brains first. When you throw a ball from one side of a room to the other, it takes one path. You can predict it. You can calculate it. Newton cracked this in the 1600s, and it works perfectly. Cause, effect, one trajectory, simple. Now shrink that ball down. Keep shrinking. Past grains of sand, past molecules, past atoms, down to the level of a single electron, and ask the same question when this electron moves from point A to point B. Newton's answer, common sense's answer, your answer would be one path, the most direct one. Maybe a slight curve, but one path. Feynman's answer, all of them. Every single possible path between point A and point B simultaneously. The straight line, the curved arc, the path that goes up, loops around the moon, comes back through the center of the earth, and arrives at point B from below. Every geometrically possible route. The electron takes all of them at the same time with no preference whatsoever. This is called the path integral formulation, or sometimes the sum over histories. And Feynman didn't just propose it as a metaphor. He built the mathematics to prove it. It became one of the foundational pillars of quantum field theory, the most precisely tested theory in the history of science. Now you are probably thinking, okay, but if electrons take every path, why doesn't my coffee cup take every path? Why doesn't it fly off in 20 directions when I push it across the table? Here is the genius of it. Each possible path has what Feynman called a phase, a kind of mathematical fingerprint. For large objects, like a coffee cup, almost all the wild, unlikely paths have phases that cancel each other out. They destructively interfere, like 2 waves that flatten each other when they meet. The only paths that survive, that don't cancel, are the ones clustered tightly around the classical, predictable trajectory Newton would have calculated. So your coffee cup slides predictably across the table, not because there was only ever one path, but because a near infinite number of quantum paths all canceled each other out, leaving only the classical one visible. The predictable world you live in is not the fundamental world. It is the average of an infinite number of quantum possibilities. The universe is, at its root, running all its options simultaneously, and what you experience as reality is just the result of most of those options canceling. Let that sit for a moment. Now here is where it gets genuinely philosophical and uncomfortable. You've probably heard of the Double-Slit Experiment. It has been called the most beautiful experiment in physics. Feynman himself said it contains the only mystery of quantum mechanics. Let me walk you through it properly, because most explanations skip the part that should terrify you. You set up a barrier with 2 thin slits in it. You fire electrons at it, one at a time, not in a stream, one by one. And you put a detector screen behind it to record where each electron lands. Simple setup. When you don't watch which slit the electron goes through, something extraordinary happens. Even though you are firing electrons, one at a time, over time, the pattern that builds up on the screen is an interference pattern. The same rippling bands of light and dark you'd see if you dropped 2 stones in a pond. The electron appears to have gone through both slits simultaneously, interfered with itself, and landed according to a wave pattern. The electron is behaving like a wave, spreading out, exploring all possibilities, exactly as Feynman's path integral predicts. Now you add a detector at the slits. You don't change anything else. You just add a measurement device to record which slit each electron passes through. The interference pattern disappears. Instantly, completely. Now the electrons behave like particles, discrete, definite, going through one slit or the other. The wave is gone. The quantum possibilities have collapsed into a single classical outcome. You didn't physically block anything. You didn't change the experimental setup. You just looked. And reality changed. This is what physicists call the observer effect, though that name is slightly misleading because it implies a conscious observer is needed. What is really happening is that the act of measurement, any physical interaction that records which path information, forces the quantum system to commit to one outcome. The possibilities collapse into one actuality. Feynman understood this meant something radical. There is no such thing as an objective reality sitting out there, independent of any measurement, just waiting to be discovered. Reality at the quantum level is not defined until it is observed. The observer and the observed are not separate things. They are part of the same physical process. Think about what that means. The question, what is the electron doing when nobody's looking, may not have an answer. Not because we don't know, but because the question itself may be meaningless. Feynman didn't claim to know what this means philosophically. In fact, he famously refused to speculate. He said, "The math works, the experiments confirm it. Don't try to make it comfortable." Which brings us to the next point. Richard Feynman had a gift that almost no other physicist of his era possessed. He could explain things simply, brilliantly, hilariously simply. He won the Nobel Prize and then spent the rest of his life giving lectures to undergraduates because he genuinely loved the act of explanation. But there was one thing he refused to do. He refused to make quantum mechanics feel intuitive because he believed deeply, stubbornly, that the universe does not owe us comfort. He said it plainly. Do not keep saying to yourself, if you can possibly avoid it, but how can it be like that? Because you will get down the drain into a blind alley from which nobody has yet escaped. Nobody knows how it can be like that. This is not a failure of physics. This is a feature of reality. Every scientific revolution in history has required us to abandon something that felt obvious. The Earth felt stationary. It moves at 67,000 miles per H-hour. The sun felt like it rose and set. We orbit it. Time felt absolute and universal. Einstein proved it is elastic. Now, quantum mechanics is telling us that before measurement, particles don't have definite positions, definite paths, or definite properties. And our intuition that they must is simply wrong. Feynman's lesson here is one of the most important in all of science. Intuition is a shortcut built from experience. And our experience is limited to the middle scale of the universe. We evolved to avoid predators on the African savanna, not to understand what happens to an electron in a double-slit experiment. The fact that the universe doesn't match our gut feelings isn't a problem to be solved. It is information to be accepted. The moment you stop demanding that reality makes sense to you and start demanding that you make sense of reality, everything changes. That is the shift Feynman embodied. And it produced some of the most accurate scientific predictions in human history, with quantum electrodynamics achieving precision equivalent to measuring the distance from New York to Los Angeles to within the width of a human hair. Trust the experiment, not the gut. Of all the things Feynman said in his life, and he said many extraordinary things, this one might be the most important outside of physics. The first principle is that you must not fool yourself, and you are the easiest person to fool. He said this in his 1974 commencement address at Caltech. He was talking to scientists, but he was really talking to everyone. What did he mean? He meant that human beings are extraordinarily good at convincing themselves that they're right. We collect evidence that supports what we already believe. We discount evidence that contradicts it. We find patterns in noise. We tell stories that make us the hero. We surround ourselves with people who agree with us and call it wisdom. Feynman called this cargo cult science, named after the Pacific Islanders, who, after World War II, built replica runways and wooden airplanes, mimicking the form of what brought resources without understanding the function. He saw scientists doing the same thing, going through the motions of research, the appearance of rigor without the actual substance of self-honesty. His standard was brutal. If your experiment produced a result you hoped for, you should work harder to find what is wrong with it, not less. You should publish the things that didn't work, not just the things that did. You should actively seek out the most powerful objection to your own theory and engage it honestly. And here is what is remarkable about applying this to everyday life. Most of us walk around with beliefs about ourselves, about other people, about how the world works, that we have never seriously tested. We mistake familiarity for understanding. We mistake confidence for correctness. Feynman saw this as a kind of intellectual dishonesty, not malicious, but deeply human and deeply dangerous, the antidote. Radical epistemic humility, being genuinely willing, not performatively genuinely, to be wrong about anything, including the things you are most certain of. Feynman lived this. He changed his mind publicly, often, and without embarrassment, he treated being wrong as data, not as failure. And that willingness to be wrong is precisely what made him so reliably right. The last idea is the one that has the most immediate practical power, and it flows directly from everything we've talked about. Feynman believed there were two kinds of knowledge. The first kind, the name of something. The second kind, the thing. And he was absolutely ruthless about the difference. He told a story about his father who pointed at a bird and taught him both its name in English and in several other languages, and then said, "Now you know nothing about the bird. You only know something about how different people talk about the bird. Knowing names is not knowing things. Knowing labels is not knowing mechanisms." The Feynman technique is his formalization of this insight. Step 1, pick something you want to understand. Step 2, try to explain it out loud or on paper, as if you are teaching it to a 12-year-old with no background in the subject. Step 3, wherever you stumble, wherever your explanation gets vague, or you reach for jargon, or you can't actually complete the thought, that is where your understanding breaks. Go back to the source material. Fill the gap. Step 4, simplify again. Repeat until you can explain it cleanly, completely, without hiding behind complexity. Why does this work? Because jargon is a hiding place. Technical language lets you sound like you understand something without actually understanding it. Feynman hated this. He believed that if you truly understand something, you should be able to build a clear explanation from first principles. The way you'd rebuild a machine from its components if you actually understood how it worked. The deeper implication is this: complexity is often a symptom of incomplete understanding, not a sign of expertise. The clearer the explanation, the deeper the understanding, the more jargon required, the more gaps are being papered over. This doesn't just apply to physics. Apply it to anything: a business model, a relationship dynamic, a political belief, a decision you made. Can you explain it simply? Can you explain why? Not just what. If not, you don't understand it as well as you think you do. And Feynman would say, that is okay. Go find out. So let's pull all 5 of these together, because they're not separate ideas. They're 5 faces of the same insight. Particles take every possible path. Reality is a sum of possibilities, not a single predetermined track. Observation shapes reality. The world is not sitting out there independently of us. We are participants in it. Reject intuition. The universe doesn't owe us comfort, and mistaking familiarity for truth is one of the most dangerous things we do. Don't fool yourself. Intellectual honesty isn't optional. It is the only method that actually works. Explain it simply. If you can't explain it, you don't understand it. Real understanding is clear. Feynman once said the universe is not only stranger than we imagine, it is stranger than we can imagine. But here's the thing: he also believed that strangeness is not a barrier to wonder. It is the wonder, the fact that reality is probabilistic, that observation matters, that our intuition is constantly wrong. These aren't depressing revelations. They're invitations. Invitations to look more carefully, think more honestly, and hold our certainties a little more lightly. The The world Feynman saw was not a cold, mechanical place. It was alive with possibility, literally, physically, mathematically alive with it. Every electron exploring every path, every observation participating in collapsing infinite potential into one actual moment. You are doing that right now. Every perception you have is an active measurement that selects one reality from a quantum fog of possibilities. That is not mysticism, that is physics, and it is extraordinary. Richard Feynman died in 1988. His last words reportedly were, "I'd hate to die twice. It is so boring." Even at the end, curiosity. Even at the end, honesty. Even at the end, no pretense. That is the man. That is the method. And it is available to all of us. Drop a comment below. Which of these 5 ideas hit you hardest? I read every single one. And if this kind of deep dive is what you came here for, subscribe, because we are just getting started.